In this presentation, I will be discussing in much more detail the construction of linguistic datasets. First, I will make some general points, and then we will be looking at 3 examples, 2 of which come from my own real recent research. I will be showing the actual datasets I have been using in computational generative grammar research projects. And then there is another example, I take it from English agreement specifically, which is artificial example, but something which I can use to illustrate the core ideas first. But let's begin with something more broad, something more general first. First point I want to make is that if and when the whole justification for our theory or hypothesis or grammar, if it comes from the dataset, in other words, in a sense that we described, I think it was the second video already where I talked about the sufficiency condition and necessity condition. So these are the 2 ways that we progress in the research. But in both cases, you can see that the dataset is really what justifies everything. We are not going to use subjective justifications. For example, we don't rely on the authority of the author who proposes the hypothesis, whether this person is influential, famous, rich, professor, student, eminent authority in the field. That's not proper. That doesn't provide the proper grounds for justification. And also, we have eliminated all subjective biases, preferences, background beliefs, intuitions, logical gaps. All that is now put aside. So what is left is simply the data set, and then the sufficiency condition, and the necessity condition. And what all this implies is that the data set will now, and the data more generally, will play a huge role in this enterprise. We are basically not stepping outside of the data set when it comes to justification. Of course, as I already pointed out, this doesn't really concern the discovery, but it is part of the justification. And so that's the first point. We really have to focus on the data sets. And then there was a second point that I wanted to at least try to explain, is that we don't actually start with the data set as such. Before we have a data set, we usually have decided on some more narrow topic or phenomenon or phenomena that we are interested in. And that's the fundamental starting point. For example, if we are interested in agreement, subject-verb agreement, my English example exemplifies this type of phenomenon, then that is the phenomenon in the real world, a tested phenomenon that we are interested in. And then the data set will be always created on the basis of that original interest, that phenomenon. The data set operationalizes this phenomenon. But we have to keep these 2 things apart, in a sense that you and me, we can both be interested in the same thing, let's say agreement, but then we might have disagreement still on how to compose the actual data set that we are going to try to explain. But as I mentioned already in some previous presentations, we have to come into agreement what the data set will be. If we both work with different data sets, or in the worst case, we are both picking up data freely, then the whole thing is pointless. We can never compare our ideas, hypotheses, and the sufficiency and necessity conditions will not play a role. All right. But let's go now into some of the details. So we have the phenomenon selected. In this first example, we will be focusing on English subject-verb agreement. So that's the phenomenon we are looking at. And we will transform this phenomenon into a data set. And there are a couple of things that we have to pay attention now. The first is that we should not allow us to leave gaps, unexplained gaps, into this data set. Again, the reason for this is obvious, because if we have a model or hypothesis that calculates some data, but doesn't calculate everything that we might have in some kind of original dataset, there's the temptation or possibility that we just remove some data points. We remove those things that our model is unable to handle. And in doing this, we would reach 100% coverage. We could say that, okay, the sufficiency condition was satisfied. We can also see this problem the other way around. Suppose that you are looking at my data set and my hypothesis, and then you see that I have some gaps in the data, what's kind of unprincipled or unexplained. Some type of constructions or sentences that should be there logically are missing. Now, this is something that allows you to doubt. Again, the skeptic can come in and start thinking, well, why are there these gaps? Is your model somehow failing here? Or what's the point? So you can see that gaps in the dataset or badly crafted datasets actually allows the skeptic again to arrive and question our claims, the whole justification. And but how do we avoid this situation? How do we create gapless datasets? And is it always even possible? Now, in principle, we can. There are cases, and I will be discussing two such cases, or actually one of my cases is basically virtually totally gapless. And that means that we take all the syntactic variables, all the elements that are relevant when we examine this phenomenon that we were originally interested in. We take all those items and elements and syntactic variables. I will show what this means soon. And then we create simply all the possible permutations or combinations of those elements. So we, in essence, we have everything in the dataset that is crucial for the phenomenon we were originally looking at. We can, so the dataset is gapless in that sense. Now, what does it mean that we take all the syntactic variables? So here I have this example now. I took a simple example from English agreement where I can illustrate what this means. English agreement is in its basic form is a phenomenon in which the subject, grammatical subject, usually in this case we use pronouns because we can make all the distinctions by using the pronouns. And then we take the finite verb. There is a correlation between their forms. We can see that the verb sometimes changes its form as a function of some properties of the subject pronoun. For example, in a present tense, if we have a third person subject, he or she, then the main verb, let's say paint, changes its form into paints. So we say that he paints the fence, not he paint the fence. But if there is a first person pronoun I, we have a different form. We say I paint the fence, not I paints the fence. So this is what we are now interested in, and you see that the pronoun and the verb, their forms somehow, there's a connection between them and there's a correlation between some of these forms. And then if we have a past tense, we see that this phenomenon disappears. All the past tense verbs are the same, irrespective of the subject pronoun. I painted, he painted. And finally, the auxiliary verbs and modal verbs. If I put an auxiliary or modal verb into the sentence, such as can, must, or did, again the agreement disappears. So I say he paints, but also he can paint, not he can paints. So the point is here that when I'm looking at this phenomenon in a completely pre-theoretical way, we can see that there are at least these syntactic factors that we have to take into account. Let's list them. The nature of the pronoun, the subject pronoun, or the subject more generally. Then we have the main verb, where the agreement form is. Then we have, let's say main lexical verb. Then we have the tense, because we notice that in the past tense, the agreement pattern disappears, or at the very least it changes. And then we have the presence or absence of auxiliary verbs and modals, can, must, did, and was, for example, in addition. But here we have also the case where we don't have any auxiliary verbs. And so if we want to create a Gapless dataset from this starting point, notice that I'm still ignoring things like personal passives or raising constructions. These are additional things that we might add into the English agreement phenomenon. We can think that this is relevant, but if we do that, we have a lot of more factors and elements we have to take into account. So I put those aside and I focus on elements that I just mentioned. So here is a kind of a situation we have now in English agreement. As I said, we ignore a lot of things and take only the basic paradigms. And to create a Gapless dataset, we take all these factors and we now create all possible combinations. So we start, for example, from the subject pronoun I. Then let's go from here. First subject pronoun I. Then we take a condition here where we don't have auxiliary. And then we go through all of these word forms. So the first sentences in the datasets are I paint, I paints, I painted. And then after that, we go through the auxiliaries. So we say I did paint, I did paints, I did painted. And I must paint, I must paints, I must painted. And once we have explored or listed all possible combinations of the two other elements and word forms with I, then we move to U and we do the same. So we create all possible combinations from these building blocks. Once we have done this, and this will already create several hundreds sentences. And if we assume that we want to, first we start with this simple domain, then all of these sentences are classified as attested or unattested, grammatical, ungrammatical, whatever, however we want to create this classification. And we create unambiguous hypothesis that is crafted or designed to capture this data set. And notice now that if I do this in this way, and if I have all the examples in the data set, then it's completely clear and again unambiguous and clear how the data was selected, why I selected it, and that I have not myself tampered with the selection. I just take every possible permutation. And vice versa. If you have this type of data set and you look, I present you this type of data and I have a hypothesis that satisfies the sufficiency condition. And then you notice that, that you never combined the modals with the past tense verbs. Then the doubt becomes, there is a doubt now, why this author, why he didn't, why this is ignored, because logically it should be. And immediately you become suspicious. Well, but could it be that this model actually does not handle that data? Of course, it doesn't have to be the real reason. Maybe I just forgot it, or it was there but was accidentally deleted when I was reorganizing the data. But that's not my point. My point is that illustrate how important it is to avoid this type of situation. Okay, so that's now a simple example. Now I have another example, and this is from my own recent real research. And this is an example where I was able to create another Gapless dataset. And just to simplify the phenomenon I was interested in, this was actually a part of a larger study for some other purpose. But in that larger study, I had to create a model of Finnish word formation, a model of how we can create more complex words in Finnish by combining more primitive parts. For example, in English, we can create a complex word like runner by combining run and then the er suffix, which creates the word means somebody or person who runs. That suffix can be added to almost any verb to create a similar meaning. And I wanted to do this for Finnish, to have a hypothesis of how morphemes can be combined in the Finnish language. So what I did was that I picked up several important productive morphemes. I had to select some because otherwise the dataset would have grown astronomically, millions of items, so that was not an option. But I nevertheless selected some frequent and productive morphemes, Finnish morphemes that can be combined together to form complex words. And then I selected 4 stems: verbs, transitive stem, intransitive verb stem, noun stem, and adjective stem. But adverbs I put aside because this was already a huge data set. So I had 4 stems representing basically all possible lexical content. And then I had, maybe it was a little bit more than 20 morphemes, elements that can be combined, suffix, to create complex words. And for this, I created separate script, Python script, which created all logically possible words that we can form by combining these elements. In other words, first we select one of the 4 stems, and then we add, first we create a series of words where we add a morpheme, one of these more than 20, and then we created in the same way all possible words where we have the stem, the lexical stem, and then 2 morphemes, all combinations, and 3 morphemes, and probably my last was 4 morphemes. No, I actually ended with the stem, lexical stem, and 3 morphemes. So the most complex words had 4 morphemes. And the script created me all combinations. In total, it was a little bit more than 45,000 words. And the purpose was to create a model for that dataset. And then in this dataset, I marked each item. That was several days of work. Whether it's attested or unattested, acceptable. Some of them were a little bit marginal, so it's not clear if it's which one it is. That doesn't matter because there are so many items, so it's a relatively small problem. And then also I looked at what could create possible meanings. It was not always clear for me if the word was impossible because it was ungrammatical or because the meaning was simply gibberish. It's a distinction that the theory ultimately should be doing. And then this forms the dataset in this study. And now I will just show what it looks like. But first of all, what I'm going to show you here is simply a text file, a regular text file that any computer program operating system can easily read, or a Python script. Ultimately, of course, this dataset, the Python script will read and analyze, or not analyze, but read this material. So this is just a text file. There's nothing fancy. You can take something like Windows Notepad and simply type these words, and that's the dataset. So let me show you how it looks like. Here we go. So here we start the dataset with words that are composed by stem plus 1 morpheme. Now, first you can notice here that I have a comments here. And that's important facility here, that the data is separated from the comments. And comments are there to structure the dataset and to make notes and comments about these items that are there, especially for those who are not native speakers. You can also see here that I add linguistic closings for most of these examples. So I explain how they are. I explain here how they are created, what elements went into them. And this is the real data element, which I have marked with the asterisks here, so it is ungrammatical. In this case, it illustrates the fact that in Finnish, normally nouns as such cannot be used as first infinitives, or here I use this term a infinitive. That's not relevant here, what it actually is. I mean, what these symbols are. Now, another point about this dataset you immediately notice that, let me take another example where I show it better. Here, number 9. You notice that the data element itself, what the other script has created, it doesn't look like a written word. This is, for example, nenäinen. But the data item here has this morpheme symbol and the other technical symbols. And that's because in this model, I still ignored all the morphophonological adjustments and morphophonological processes that happen when complex words, when we just have their parts, are translated into phonological and ultimately in speech into phonetic materials. So that was ignored. So that's why the words themselves are notated more abstractly, and we work with these more abstract elements. In other words, these are simply linear sequences of morphemes, not the actual words as they occur in the speech or written text. And sometimes when the mapping is non-trivial, as you can see here, I have added myself a comment that how this word should look like when it's written. So nenäinen, for example here, nose-like, or somebody who has nose. If I say nenäinen patsas, it's a statue that has a nose, or a somehow exceptional nose, for example. Adjective from the noun stem. So the dataset should have this kind of information, and not just the actual items. Nenämäinen, there's a similar situation here. Nenämäinen is also adjective, like a nose, resembles a nose. I have tried to characterize the meaning here, again in a comment. Nenätön, this is a nose, that somebody has no nose. Nenätön patsas is a statue without nose. So you get the point. So here we go then, if I look at this data set quickly, you can see that we do all possible lexical stems with all possible suffixes. And then if I go forward, we get to the next class, which is two morphemes. Nenättää, nenättäjä. For example here, you can see that it's a nose, causativization, and the ja, which is the agent. So nenättäjä is somebody who is, for example, creating noses for statues, is causing them to have nose. It's composed from three morphemes actually. And so we go here, all the I think it was 46,000 or something. And when we get more and more complex words, then most of these elements are completely gibberish, ungrammatical. Let me see if I can find one more example here of a complex word that turns out to be possible. And there's one thing that I wanted to say here, that because we create all possible combinations, there are really what you would initially think is completely crazy ideas. So for example, it creates all words where we have repetitions of morphemes, which are completely out of question in a real language. I think I saw here something that was grammatical. Maybe I missed it. Let's go this way. Here was something, for example, now I just, with this, which is a difficult word, and you can see how this very fast becomes quite crazy. So I have here something like istuvuusmainen. Now this word is created first taking the intransitive stem istu, to sit, then us, which creates kind of abstract nouns, things like istuvuus, which is like it's like the propensity of sitting, or something that sits well. And then we have nominative case, the empty suffix or zero suffix. And then we can still have mainen, which is the adjective, adjectivizer, creates an adjective. So something that sits well and is something like something that sits well, something like that. And but the interesting part of this word, which again shows how this Gapless dataset, how interesting questions they bring us. So you can see that the nominative case is here in the middle of the word. Now this is not obviously possible if it's some kind of, because the nominative is a zero marked suffix. So it doesn't really matter. But if it is something else like partitive, this never happens. The case suffix has to be the last element. Not the last, because there can still be clitics, but in this series what I'm using here, definitely the case cannot be in the middle of the word here, but the nominative case is zero marked case. So why can't the nominative case then be in the middle somewhere? If it doesn't show up as a phoneme or as a morpheme. Indeed, why? And this method generates this kind of weird words you can see here where I'm doubling the nominative case. So what really prevents this if there is nothing visible? I don't have an answer to this. I don't know how this should be dealt, this question. This was a surprise to me when I generated this dataset, and I wasn't really focusing on these case suffixes. I had to use them because some Finnish words are such that they require a case suffix in order to create acceptable word. So I had to include this nominative case to the dataset. There is no other case suffixes included. But then it created me these weird words where I'm doubling them. And that is acceptable because there is no morphological exponent visible. As I said, I don't know the answer to what the proper way to deal with this is. Here you can see that I mark them as acceptable. And here also, even if it's between the words, between the morphemes. Because the outcome is acceptable. Anyway, I leave this problem for you. I don't have the answer how to deal with this situation. They are kind of hallucinated nominative cases, hallucinated invisible nominative case elements. Anyway, let's move on now to another example. This was just an example of how we can create Gapless dataset. I have another example I'm not going to discuss here. I did a study about Finnish word order. And when we are dealing with word order, it's quite easy again to create Gapless dataset by simply taking a construction class, like let's say finite transitive clauses or finite transitive clause with an adverb. And then create all permutations, all possible word orders, and that's the dataset. I had more than 100,000 sentences in that dataset, and it was too ambitious project. That's too much. I managed it still, but that's too much. It's too much work, and it was the whole problem became too complex when I had so many sentences in the dataset. But anyway, it's easy to see how word order can easily be treated in this way. Now, the final example I'm going to discuss here is one where this Gapless creation does not work. And the reason is because the phenomenon involves so complex issues, complex constructions, and complex syntactic variables that it's not possible to create all the permutations without making an astronomically complex dataset that would have millions of expressions. Now the problem is actually not in the amount of expressions as such. The script that I'm using can calculate through 1 million examples. I would just leave it overnight. Rather, the problem is that I still would need to judge all this dataset myself to provide the gold standard judgments. And it's just too much work to do that alone for 1 million expressions. And not only that, but remember that when we create an hypothesis and we calculate something and we see that there's a problem, the model is not working correctly, and then we go back to make corrections, we have to recalculate everything. So it's not just that I calculate the dataset once. I have to do it hundreds of times. So then 1 million items already becomes quite heavy. I think that with parallel computations, and if I would create a script, improve it so that it would be able to slice the dataset into several independent blocks and do that in parallel, we could improve the situation. But still, do we really need at this point to work with such a large datasets? I doubt it. Maybe in the future, and maybe likely also in the future, this will be the case, but it's not the case now. Okay, so what can we do in that scenario when we can't do completely gapless datasets? Then what we still can do is we have to exclude some possibilities, but we can do that exclusion in some systematic way, and we can report the exclusion explicitly. We can exclude whole huge segments of data instead of excluding willy-nilly random examples from here and there. And also we can simply admit that our hypothesis is justified not by gapless data, but data that has excludes some possibilities. So it's simply admission that the hypothesis is not justified fully, or it is justified, but the dataset is not ideal or optimal as it could be. So this example where I illustrate the situation, this involves Finnish second position clitics. I wanted to understand their properties, and this study, as I'm recording this now, is not yet published, but I've basically done it. And the model is, I think it made 3 mistakes, which I decided to put, simply acknowledge and put them aside, because they involve things that are not really that important to me. But here is the dataset. And this is again the same, it's a text file, simple text file where we have here some type of classifications, again, so that I keep myself track of what I'm creating, what the data is representing. These are not processed, these sentences. And here are the sentences, and then I will have simple closings, which the model script, the executive layer is not, it will ignore these. And the clitics themselves are this type of suffixes, enclitics, which are added in Finnish to words that are usually the beginning of the sentence. In this case, it's the finite verb. The canonical word order in Finnish is SVO, subject, verb, object, but here you can see that the verb has been moved or occurs in the first position. And this has to be the case if I add any of these second position clitic to it, so it can't remain in its canonical position. I show some examples later. And what happens, let me just use this example so I don't need to go through all this data, it's not relevant. So the ko is yes, no question clitic, which creates interrogative clauses with the yes, no meaning. So maalasiko Pekka aitaa is asking, did Pekka paint the fence? It's not the only interpretation, but that's the canonical or standard meaning that the native speaker would create here. Maalasiko Pekka aitaa, so you can answer yes or no. That's a natural way of answering this. And the ko is the critic which creates both. It encodes the fact that this is interrogative, it's a question, and then it represents the fact that it's a yes-no question. Now what I'm doing here is that I'm taking all of these critics and their combinations, and then I take this simple sentence type or class where the verb is the first element, and I create all the combinations. There they are. This fog is a prosodic feature. It represents focus stress. So I'm emphasizing this word also prosodically. And then I take the same, but I'm using auxiliaries. So this is the baseline sentence. Pekka on maalannut aitaa, which is Pekka has painted the fence, or Pekka has been painting the fence. And then I again do the same. I combine this auxiliary, which occurs in the first position, with all of these second position clitics and their combinations. Negation, They can be combined with negation also. They can be combined with interrogative pronouns, kukas, kukapa, kukako. It's actually interesting that in Finnish you can take an interrogative pronoun and add yes, no, clitic. And still it's grammatically acceptable. Object pronouns, and clitics. And then here we start to test also ungrammatical, unattested variations. For example, here I'm trying to create a sentence by adding the yes-no clitic to the object, but without moving the object to the beginning. So the sentence is Pekka on maalannut aitaako. And this can be functioned marginally as a kind of a echo yes-no question, but it's still not good. And it definitely, the standard or acceptable form that you can attest is simply aitaako Pekka on maalannut, where the fence which carries the clitic is the first position, and the clitic is sort of second position then. So I'm testing these in situ variants here with all of these combinations and with all the words. So here we sentence, for example, Pekka on maalannutkohan aitaa, where the verb occurs in its canonical in situ position, and then I combine two critics on it. And that's ungrammatical, unacceptable, unattested. Finnish speakers would not normally use this sentence. And so on we go other in situ variations. I will just scroll this because the example I want to talk about here comes later. I just find it from this dataset now. Here, just to mention, I'm testing double-filled sentences where we have this clitics repeated or in several words. Sentences like aitaako onko Pekka maalannut, which is like fence plus yes no clitic, auxiliary, another yes no clitic. These are all ungrammatical. Aitaahan onhan Pekka maalannut is not acceptable, the same there. And all sort of variations. I just skip this because that's not my point, and I'm not the actual empirical phenomenon, and my theory is not the point here. Okay, this was what I was searching for, the clitic combinations. Now, as I already mentioned in the beginning, in Finnish, we can combine these clitics. We have this kind of forms such as Pekka-kohan. So here we have the yes-no clitic and combined with this what is called familiarity clitic, han. And then in this example we have also, this example we also have the prosodic focus. So this is supposed to be Pekka-kohan. It's supposed to be somehow emphasized even, an additional emphasis there. But only some clitic combinations are possible. And here in this data segment, I'm trying all the clitic combinations. So first we start with ko, so meaning that the first clitic is ko, and then we try combinations where the second is the prosodic focus, and then we just go through all of them. So here we have Pekka koko, for example. It's not possible because these can't be repeated. And this was interesting phenomenon that I could actually even myself I could accept the repetition of familiarity clitics. So I could accept perhaps this kind of sentence where you say Pekkahanhan sieltä tulee, where is a double han, but then other Finnish speakers I consulted didn't accept this. That's some kind of unclear case. Perhaps I'm wrong and my grammar is just confused there. Perhaps in reality, if I see this written text, Pekkahanhan, it would not really be accepted so much. It's not anyway, we test here systematically all clitic combinations so that our model will be filtering out unattested forms. and we are testing all combinations. But we are not testing all critic combinations in connection with all other constructions. So if you remember what I showed in the beginning, the first sentences where we had, for example, let's say the auxiliary constructions where it was the auxiliary verb that was fronted, and then there was a clitic and some clitic combinations. But we had only some clitic combinations, namely those which are grammatical. If we would do a Gapless dataset, I would have to test that auxiliary construction in connection with all clitic combinations. And the same for every other condition, the verbs, the fronted verbs with all clitic combinations. Then I would have to take all the in situ ungrammatical examples in situ and use all clitic combinations also there. So there would be sentences that are sentences that have multiple problems. First, the clitics are attached to a wrong word in the middle of the sentence, and then they would have some kind of bad clitic combination. Let me give an example. For example, Pekka maalasi aitaa, Pekka painted fence is the baseline sentence, and now we add one critic to the middle of the sentence. We would say Pekka maalasiko aitaa. Maalasiko is a verb plus the yes-no critic. This is ungrammatical because we would need to move the verb to the first position. But then we should also test Pekka maalasi koko aitaa, where the koko, that's a problem because koko means also all or whole. But let's say Pekka maalasi han aitaa. And Pekka maalasi han aitaa should be also be tested. So there are several variations, several problems in that kind of sentence. So that would be a Gapless dataset. But here it was simply not possible because it would create such a huge astronomical dataset. So I decided that I will be testing the clitic combination only in their own segment, where I'm using subject. They seem to be attached to the subject in every case. In other words, I'm just testing the clitic combinations here without checking that it works if it's object or subject or the verb or whatever it is, or in situ. Well, is this a big problem? You might first think that it's not so big problem, that if I'm showing that the repeated clitics are ungrammatical, Pekka koko, for example, is not acceptable. We can't have a double yes-no clitics. So you would think that, okay, but then it's trivially true that if I put this double clitic word into the middle of the sentence, into a wrong place, you would think that, okay, but it can't make this sentence grammatical, so it has to be still calculated correctly. Or you might think that, what does it matter if the critic combinations are tested in connection with the subject and, let's say, with the verb? But this is totally incorrect. My own practical research has shown that what the human mind thinks that is trivial often turns out to be nothing but. So it's not only that there are so many side effects of all of our theoretical assumptions and that the models that we cannot calculate them all in our mind to be so sure that the double clitics in the middle of the sentence would not suddenly turn it into grammatical. And even more than that, it's not just simply that, but it's that in most cases when we do this type of combinatorics, it's not really the true often that everything goes wrong, but rather what happens is that this combinatorics or this these expressions where we do this combine these elements, some of them create by kind of accident, or they are kind of edged cases where our theoretical assumptions conspire to create a wrong result. This happens all the time. So even if the model would correctly judge Pekka maalasi han aitaa ungrammatical, because we have a triple critics in the middle of the sentence, there could still be some weird case where these assumptions conspire together to create a wrong judgment. And so really, we can only say that if I have a model, as I have now, that calculates these data, almost all, that the justification of that model or hypothesis is restricted to this data set. That I can't really guarantee you that if we take everything into account, that it will still work. I can't claim that. And so you are entitled to be doubtful. You can be a skeptic and say that, well, the sufficiency thesis, yeah, it's satisfied by this data, but I'm not sure that you have captured the whole phenomenon yet. Okay, that was an example. Another example, then there are still more worse cases. Sometimes the data is so complex and the phenomenon is so complex. This is especially when the constructions themselves, like if I'm studying something like the island phenomenon, double H movement and restrictions, I can imagine this is impossible. So then we have to, then the only way is simply to proceed in a smaller steps, and then as a collective, as a group of stakeholders who are interested in this phenomenon, to gradually increase the complexity and the completeness of the model. Well, that was all I wanted to include into this presentation. It has already been quite long. Just to summarize, if we begin with the methodological principle where the justification will always be based on the data, and we ignore all the subjective elements and beliefs and authority and all the human attributes from the justification, in that case the dataset will play a huge role and be the crucial component. And so the dataset creation is really an essential step in this research field, in the computational generative grammar research. And I just showed you some of the ways we can proceed here. We can do gapless datasets, or datasets that are composed systematically, but where are gaps because we can't simply include everything. But then these gaps are removed systematically, and the existence of these gaps is also acknowledged. And this will be the datasets, and I demonstrate how they can be simply text files with some comments and clarifications added. And these text files and these text files and the datasets will then be processed by the computational scripts. So they are not just there existing. This is literally what the script is reading and analyzing and working with. And finally, these datasets that I've shown you here, they are created by me for my own research purposes, and they are deficient or problematic already on such grounds, because I think that, and I believe strongly that the only way we can create useful datasets, or the way we can eliminate all doubt or most of the doubt is to do these sets collectively. So we select a phenomena or phenomenon, and then together everybody who is seriously interested in explaining, understanding that phenomenon will participate in this data creation. And we would proceed by criticizing each other's proposals and think very carefully what to include, what to exclude. So what I presented here is not meant to be any kind of not even good or final datasets.